All right, Jerry. So we're gonna go out here and chuck a couple oysters.
Great. Do we need to dive for them first?
Could.
I've never eaten in a boat.
Cheers.
Cheers.
Down the hatch.
Tastes like the sea.
Did you chew it?
Yeah.
Good. Over the side.
Very salty.
Mm-hmm.
Yes, please.
Those were salty, but they get sweetness too.
Mm-hmm.
I'm Joff Davis, and we're sitting here at the NOAA Manchester Research Station. NOAA stands for National Oceanographic and Atmospheric Administration, and the research center here is the Northwest Fisheries Science Center.
So what specific research are you doing here?
We are looking at trying to figure out and develop genetic lines of Pacific oyster and other economically, commercially important shellfish that will grow better and faster and survive better.
They look like dirt.
They do look like dirt.
Especially in light of ocean acidification issues that are ongoing and increasing, and also due to potential emerging disease threats to shellfish. We noticed about 10 years ago that there were some very, very serious things going on with trying to produce shellfish seed. For whatever reason, the pH of the water that we were bringing into the hatchery was just super low.
What causes ocean acidification?
We do. The vast amount of carbon dioxide that's pumped into the atmosphere, power plants, cars, agriculture to some extent, you name it. We're pumping CO2 and methane into the air, and that they're greenhouse gases. And by increasing that amount of CO2, carbon dioxide, and seawater, it creates slightly acidic conditions in the seawater. And that essentially is ocean acidification.
So this would be like if all of a sudden our air became acidic.
Correct. It's well over 400 parts per million in the atmosphere, and it's also increasing as dissolved carbon dioxide in the oceans.
Is it 350 parts per million the tipping point?
It's gone down about a little bit over a 0.1 pH unit. So 0.1 unit is about a 30% increase in acidity of the open ocean. And then the OA problem is exacerbated near shore, especially in a place like Puget Sound, because we're also pumping in nutrients into the water just from runoff, just from the fact that there's many people living in the space. So really the critters that are most impacted right now are ones that use, that have to calcify their shells.
So what are you doing here to deal with this problem?
This particular project was looking at taking a pretty large number of different genetic lines that we generated in the hatchery, and then exposing them to a ocean acidification challenge.
Wow, okay, so they're really wiggly. They look like, maybe like horseshoe crabs. I think they'd make good pets. Yeah, so how does this process work? How do you change the DNA of an oyster to be more resilient?
Our specific approach is to generate lines of oysters. And by a line, I mean a genetic family. And they're unique, just like your family and my family are genetically unique. And depending on how those lines perform, we will pick the winners and losers.
So are you sure that all of this work that you're doing and this research you're doing is going to work?
No. In fact, that's the nature of research. So we won't know until we actually are able to thoroughly test and rigorously assess the outcomes. So it truly is a competition amongst the different genetic lines to see who wins. They just sit on the beach and they basically suck in seawater, and some will do well and some will not.
That sounds like a pretty nice life.
Oh, it's a great life to be a mollusk, yes. Why wouldn't a mother would produce 100 million eggs? But so bad choices are made all the time.
Does she love them all equally?
She absolutely loves them.
Like all parents?
All parents.